Guys, so the first thing we're going to talk about on our note packet is temperature and heat and kind of how energy plays a role in that. And so energy is the ability to do work. And we use energy to do all kinds of things. We use energy to push a desk across the room, or if we need to move our bodies. We also use energy in order to break down our food as a chemical process. And so energy is measured in joules. Oops, sorry about that. Energy is measured in joules. And so the symbol for a joule is a capital J. And it is spelled differently than, diamonds and emeralds and things like that. So that's a different kind of joule. And there are two main types of energy. So you either have potential energy or you have kinetic energy. Now, the key thing about the difference between potential and kinetic is potential is stored energy. So it means like if I say I have the potential to do something, that means it's within my capabilities. I have the energy within me to do that. Whether I actually do it or not is different. But so potential energy is stored energy, and kinetic energy is the energy of movement. So when things are moving, they are using kinetic energy. And so in chemistry, we talk about chemical potential energy specifically. And chemical potential energy refers to energy that is stored in the bonds. So in the bonds of molecules. Okay, so for example, if I have water, so if this is my water molecule, then there is energy in this bond here. Okay, and it's going to either, in order to break it, you're going to have to put energy into it, but when the bond breaks, it will actually release energy out into our system. And so kinetic energy, the energy of movement, when we talk about this, we're referring to thermal kinetic energy. Okay, and this is because energy and thermal, guys, thermal means heat. Okay, because what heat does is we're talking about the movement of atoms. So how heat can speed up or slow down the movement of atoms. So if you're adding heat to it, they're going to start speeding up. If you're taking away the heat, the atoms are going to slow down. So heat impacts the movement of atoms. And so a key thing to understand is that the law of conservation of energy refers to that in any chemical or physical process, energy is conserved. Okay. Oh wait, that's a different part of our notes. Hold on one second. Energy is neither created or destroyed. Okay, you cannot create your new energy. You can't get rid of it completely. It's just transformed. In order for me to run a marathon, I have to eat food. The energy is being transferred from the food into my body, and then it's transferred into ATP that my muscles can use. Okay, energy is transformed through different processes, but it is also conserved, which means that it is saved. Okay, it does not go anywhere. Now, all energy can be accounted for as three different things. It can be accounted for as work. Okay, this is used often more in physics class. You'll talk about work, the work you need to push a box across a floor, or for a roller coaster to go up the little hill and then go all around the roller coaster track. But in chemistry, we're going to talk about how energy can be accounted for mostly as either heat or as light. So these are the two that we focus on in chemistry. And so heat can really impact and is the reason why we have 3 different phases of matter. Okay, the first one that we are going to talk about is a solid. Now, as a reminder of our first semester content, in solids have strong intermolecular forces. Okay, this means that the forces holding the molecules together in that solid piece are very strong. And so with the spacing of the atoms are very close together. They are very close together. And so we'll just kind of also write that over here. They're close together. And when we refer to how they're moving, they're vibrating, but they're vibrating in place. So they're not moving around. So for example, the screen that you're watching this video on, the atoms are vibrating in place, but your computer is not moving all around the room, or your phone is not jumping from your hand onto the floor. Okay, the atoms are vibrating, but they're staying in place. And so in a picture, this would kind of look like these little lines that go around it to indicate movement, but specifically vibration. So that's what those little lines mean. And so this means that a solid is going to have a very low amount of kinetic energy. There is not a lot of kinetic energy in a solid. In a liquid, the intermolecular forces are going to be weaker, so they're going to have weaker intermolecular forces. This is because the liquid molecules, they are going to be moving more, so they're going to be further apart. Okay, but so let's see, further apart. But the key thing is that with those forces, they're still connected. They still have those intermolecular forces connecting them together. And so what happens is the molecules are going to flow in the same direction. So when they move, they're not just vibrating in place, but they are moving in the same direction. So, and we refer to how they move as saying they're flowing. So they flow in the same direction. That's key. If I pour out my water bottle, or if you look at a river, you don't see half of the water flowing one direction and half of the water flowing in the other direction. It's the same direction. Now, with the kinetic energy, they're going to have, I don't know, we'll just use medium for lack of a better term, but a medium amount of kinetic energy, definitely more than a solid, but they're going to have less than a gas. And so a gas is going to have no intermolecular forces connecting them together. And so that means the atoms are very spread apart, but it means they're also moving in different directions. They're not being held to the same direction or things of that nature, but they're far apart. Okay, you know that if you've been in a car when someone farted, it did not just stay near them, it spread out through the whole car. So those gas molecules move fast and they move far around, they fill up their container. So with the movement of atoms, they're very fast, and it's in different directions. That's a key thing there. And then with kinetic energy, they have the most amount of kinetic energy because their speed is so much greater. So when you think about kinetic energy, think about speed. If they're going very fast, they have a lot of kinetic energy. If they're moving slowly, then they have a low amount of kinetic energy.